So for today's lecture, we're going to be going over modules and packages in Python. This week, the slides were created by Gaurav. So huge thanks to him for taking the time out to create these slides for us. It helps me out a lot especially with me being busy last weekend. It helps a lot to have him as an assistant creating these awesome slides. Yeah. Cool. So a module. So a module is a file which consists of Python code like hello world.py. A module allows you to organize your Python code logically. It's a good programming practice to keep related code together in a file. And then, along that same vein, code that's not necessarily related, you would want to separate out into different modules. So in this screenshot down here, we can see there are 4 modules in this PPiAI folder. So we have assignment4.py, input and output.py, and loops.py. All of these contain Python code. You can probably guess that some of these are from basically previous lectures. These are actually probably where Gaurav had worked on the assignments for providing assignment answers, and also just taking the screenshots that we use in the lectures. Because these are the lectures that he's covered: input and output, loops, and then now this modules and packages. So yeah, often you'll keep them separated logically. So input and output and loops are logically separate here, and then assignment 4 logically separate as well. But then the code inside of them, in this one, it's usefully named input and output. So all the code in there is going to be related to IO, and then loops, all the code in there is going to be related to loops and such. So with modules, you can use any Python file as a module using the import statement. So up here, we have this assignment4.py module. And in it, we have welcome text1 and welcome text2, and with some values assigned. In this other loops.py file, we can then import assignment4 because, on the previous slide, they're in the same folder here. So this assignment4 file is accessible to the loops and input and output file. So you can import that whole file using the import statement here. So this is importing assignment4, and notice we don't put the .py at the end, but this does import this whole file. And then what we can do is we can access the variables defined in another module using the dot operator. So right now we have we've imported assignment4, and then in this print statement here, we're taking assignment4 dot welcome text1. And so we're referencing the welcome text1 from the assignment4 module there. And then we actually have access to that variable. So when we print that out and we run this file, now we can see in the output to the console here, we see the IAMAssignment4.py module variable 1, which is the value of that variable in here. So this is like a really simplified approach for how you can access another Python file from one of your Python files. Super useful for when you want to keep your code logically separate, but you still maybe have like a main file where so you have like a bunch of different functions for different use cases, and then you have like a main file where you want to reference all the different functions and variables that you have in your other files or other modules at that point. So when the interpreter encounters an import statement, it executes the entire code of the module. So in this particular case, now we've added print welcome text2 into the assignment4.py file. So now when we run loops still has the same exact code in it. We're importing assignment4 and then printing assignment4.welcome text1. So now when we execute this file, we'll see in the console that we have IAMAssignment.py module variable 2 output first, and then we'll see the IAMAssignment.py module variable 1 output second. So what's happening here is when we import assignment4, all the code in the assignment4.py file is executed. Since that code includes this print statement for printing welcome text2, we see welcome text2 output to the console first because we have the import statement first. And then after that, we have our print statement that's in the loops.py file, which we're executing. And that just shows the assignment for.welcome text one. So deorder kind of calls out what's happening here. But yeah, anytime you import a file, it'll execute all the code in that file. So essentially what's happening when we import assignment for is that we're creating a variable welcome text one, welcome text two, and then we're printing welcome text two, all within this import statement here. And then we can reference all of the things that were executed within that assignment for.py file using this assignment for name. And then we'll see ways that we can get around that, so we don't have to always have assignment for dot whatever for that particular case. So any questions on this so far? Okay, cool. So Python's from keyword lets you import specific attributes from a module into the current namespace. So say for whatever reason from assignment 4, we only wanted to import welcome text 1. One of the reasons we might want to do that is because, so far all we've done is output welcome text 1 on these previous slides. So we don't actually need welcome text 2 or anything like that from our assignment 4 file. So if we want to just import welcome text 1 from there, because that's all we're referencing, then we can do from assignment 4. So like from the module or package that we're installing from, import, and then the value that we're trying to import. And in this particular case, we're importing a variable, but this could be a function name. Say we had a function named like, assignment 4 function 1. We could have imported the assignment for function 1 and then been able to use assignment for function 1 inside of this loops file. So now we don't need to use the dot operator anymore because we've imported welcome text 1 on its own. So it's independent from assignment 4 at this point. We don't actually need to reference it through assignment 4. So we can just output welcome text 1. Basically what this is doing is it's creating a variable welcome text 1 inside of this environment up here. Using what we grabbed from the other module up here. So this is a really useful means to avoid having to always do, package name dot or module name dot, and then whatever you're trying to reference there. So you'll often see from whatever import whatever. You'll usually see that pattern instead of just an import assignment for. But you'll see both, like we've done in the past, like we imported IO for doing the file and package operations. So we just did import IO, but then something you might have noticed is every time we referenced a function from IO, we always had to do IO dot whatever it was. So like IO dot read file or something like that. So if we want to install all of the things in the package without having to list them all out up here, because we'll see in a future slide that you can also list things out. So we could have done from assignment 4 import welcome text 1 comma welcome text 2. That would have imported both welcome text 1 and welcome text 2 here. But say we don't want to list that out. Sometimes in our module we have a bunch of different variables and functions, and we want to import all of them. We want to be able to have the ability to access them without having to do the dot notation, the like module or package dot whatever. We want to avoid that aspect. So then, but we do want to import everything, then we can use the star symbol. And oftentimes you'll heard this as like splat. So we use the star symbol to import all names from a module. So from assignment 4, import splat. And that imports so that now welcome text 1 is available just like it was up here. And then something else that we could do here is we could have welcome text 2 as well. We could have printed welcome text 2 down here because that's also going to be available since we're importing both variables from assignment 4 or from the assignment 4 module. And it's not just, it would be any other variable or function we had in there by using this splat notation here. Yeah. Any questions on the from statement?
Yes, I have question. Hello, yeah. David. Can you hear me? The asterisk to import that is putting that asterisk in place of the variable. Does it mean it's going to import only the one you are printing out, or is going to, when you say print welcome text 1, is it going to print both text 1 and text 2? Welcome text 1 and welcome text 2 together?
So this would just print welcome text 1, because basically what this is doing is it's importing both of those variables to our environment. So we have welcome text 1 available, but welcome text 2 is also going to be available in this environment as well. So we could have another print statement for printing welcome text 2, but when we print welcome text 1, it's only going to print the value of welcome text 1. It won't also print the value of welcome text 2.
Oh, that's great. Okay, thank you.
Yeah, of course. Thanks for the question. Great question. Any others? All right. All right, so for packages, a package consists of multiple Python files. Basically, it's an entire folder structure that consists of modules. So in here, we have this root PPiAI folder. This is our overall project. But then inside there, we've created another folder, PPiAI here. And in that, we have 2 modules. We have module 1 and module 2. So this is essentially a package. This PPiAI folder can be treated as a package. So now within that package, we have multiple modules, and that's really the advantage to using a package here. You can have multiple modules within a single package. So say you have something that's like a package that's all related to math or something like that. So you have so you might have a folder named math, but then underneath that, maybe you have a bunch of functions that are related to addition, a bunch of functions that are related to multiplication, a bunch of functions related to getting the area of objects, a bunch of functions related to getting the volume of objects, etc. Maybe you want to keep those logically separate. So you can have like like addition.py and then a subtraction.py, an area.py and a volume.py folder in there. So they're all still logically separate, but they all kind of roll up into the math folder at that point. So so this is really how you'd create your own package structure here. So again, a package consists of multiple files. Basically, it's an entire folder structure that consists of modules. But we can also import that that whole package, or we can import just some part of that package. So let's see, let's start over here. So we're looking at module 2 here, and remember module 2 is under the PPiAI folder. So we can I can access module 1 from module 2 because they're in the same package. So module 2 is right here. Within that same folder is module 1. So I can simply import module 1 from module 2, and then I could print out module 1.welcome text, assuming module 1 has some welcome text in it. And that would print out whatever the value of welcome text is in module 1. Because even though we're in module 2, we're able to reference module 1 from there. But if we're in the assignment 4 file, so assignment 4 is at the root level of the broader PPiAI folder. So it's not within the PPiAI package in here. So it's at the same level as that PPiAI package. So if we want to reference module 1 in assignment 4, now what we need to do is we need to import PPiAI, and we can also import just specifically module 1 from there. So what we could have done here is we could have just done import PPiAI, and we could have printed PPiAI.module1.welcome text 1, or we could just or we could do what Gaurav's put here, where we do import PPiAI.module1, because say we don't need module 2 in this particular case. We just want to import module 1, and then we can reference the welcome text 1 from that from this assignment 4 file after kind of digging into the PPiAI package. So we're using dot notation here to go deeper and deeper into the package. So we start out with the PPiAI package, and then dot the module name that we want to get into. So we have module 1 right here. And then when we're actually trying to reference a value inside of module 1, we're going to have dot welcome text 1. So we start at the broadest point with PPiAI dot, so the PPiAI package dot the module name dot the value within that module. And this can keep going, really. Like, so right now we just have this single folder in here with 2 files underneath it for our package. What we could also do is we could have like we could say we had PPiAI, and then we had like a week 1 folder, and then like an assignment 1 folder in there or something. then we could, keep recursively going through that to get to PPiAI dot week1 dot assignment1 dot whatever value we want from assignment 1 there. So just keep in mind that you can keep digging deeper into packages using dot notation. You just kind of have to go logically through the file path to get there. So any questions on that? Cool. All right, so as mentioned previously, you can import multiple things from a package in a module, and we can use the comma to import the multiple modules or packages in a single line. So up here, you'll notice that we have package 2 in the PPiAI package over here. In this import statement, we're importing the whole PPiAI package, and we're importing package 2 as well. We're using a single import here, and we're just separating those by commas. So we're able to import PPiAI and package 2 all on one line, just using a comma here. And then we can do the same thing with modules. So thinking back to the first slide where we had loops and input and output on the same level as our assignment 4 file, we can also just import loops, and we can import input and output as well, again on the same line using commas here. So we're importing our packages up top, and then we're importing our modules down here. And this same logic applies with the from operator or the from keyword. So if we had, from PPiAI import, say we wanted to import both module 1 and module 2, we could do from PPiAI import module 1 comma module 2, and that would import both module 1 and module 2 from the PPiAI package. So, if you want to import multiple things, you can use the comma separator here. Just make sure that if you're using the from, if we're doing like from PPiAI import, you can't then also import package 2 on that same line. The reason for that is because package 2 is separate. It's logically separate from the PPiAI package here. So what you would need to do at that point is you'd need a separate import statement for package 2 at that point. But if you're importing the entire package, then we can import PPiAI comma package 2. They're at the same level here. So you kind of want to think of it as, are they at the same level? If they're at the same level, then you can separate them with a comma. But as soon as you dig a level deeper by going like from PPiAI, now you can from PPiAI import, now you can only import things that are in the PPiAI package in that single line. So you can't import from multiple levels on a single line, if that makes sense. I did not mean to do that. Okay, and then we use the as keyword to import modules as custom names. So in this particular case, we're importing PPiAI.module1 as my module. So if for whatever reason when you're importing something, say you're importing a package that has a super long name, like you don't want to have to keep typing out that super long package or module name every time you use it, right? So a way you can get around that is by using this as operator. And then you can just name it whatever you want. And this is a completely arbitrary value. It doesn't have any meaning except for that it's like storing this package in a variable in a way. So now I can print my module.welcome text1, and what this is going to do is it's referencing the PPiAI.module1. So we're actually referencing the code in module 1. My module is basically an alias for PPiAI module 1. So the welcome text1 that we're outputting here is coming from the module 1 file from our PPiAI package. So so this is usually useful for, like, there are situations sometimes where you're trying to import a particular package, and that package has, so say you have a variable in your code, and that variable is called math, but you need to import the math package for whatever reason. You then, in that case, you try to import math, but then you're trying to use this math variable as a separate thing from math. You're going to end up with a naming conflict there. But you want them to stay logically separate, but you don't want to rename your math variable for whatever reason. What you could do then is you could do import math as MT or something, just abbreviate math, or import math as mathematics or something. And then you could use that reference to that name, that MT or mathematics name, to reference your package, the math package, and then you can use your math variable to continue referencing your individual variable at that point. So that's where it really gets useful. The two cases where it's really useful is when you have a long name, like you don't necessarily want to keep typing out PPiAI.module1 dot welcome text every time. You just want to rename it as my module so that you only have to put in my module at that point instead of all this stuff over here. Or if you have a name collision and you have a variable that you don't want to rename, or there's something else in the code that would conflict with that variable, like say another package. So you're importing from two packages and they have a function that's named the same thing. You can alias the function of one of them so that you can use both of those functions in your same code. So that's really the usefulness of as at that point. Any questions on that? Okay, cool. So why packages and modules are needed? The answer is modular programming. Modular programming refers to the process of breaking a large, unwieldy programming task into separate, smaller, more manageable subtasks or modules. Individual modules can be combined like building blocks to create a larger application. So the advantages to this are simplicity, maintainability, reusability, and scoping. So from a simplicity perspective, you're able to logically separate everything in your various modules and packages. So if you need to go in and you need to edit, so you say you have this big package and part of it is related to some high-level math functions. Instead of having to search one large file for this high-level math function, if you package it into something that's like a math package, and then in there you have like a high-level functions module, it's easy to go and find that bit of code that you need to edit or work with. So it's really simple to go and find that. And because of that, that also makes it really maintainable. It makes it easier to find your functions at that point, and to edit them should they need editing. So you find a bug in it, you need to find that function to be able to edit that bug, or fix that bug. So then that really increases maintainability there. Also with reusability. So if you have some code that you want to use across a multitude of different files, a multitude of different applications, you don't necessarily want to copy paste that code from one place to another multiple times. Just like with functions, anytime you're starting to copy paste code anywhere, that means that if you have a bug in that code, you're going to have to go edit that code manually in every single place where that code exists. But if you have a package or a module that has that code in it, then you find a bug in it. So you have this package that has that code in it. You're referencing that package from all of your other files. Say you have 10 files that are using this package from there. Now you find a bug in it, you only have to go fix that one place, and it's basically automatically fixed in every other place because every other place is just importing from that code there. So it makes it really reusable at that point as well. And that's part of the maintainability as well. You don't have to go into 10 different files and change the same code in 10 different places. You just change it in one place. Since you're reusing that same code by importing it into multiple different files and applications, then making that edit applies that edit essentially everywhere across your code base. So it's really useful in that sense. And then also for scoping. So when it comes to scoping, we want to make sure that, as we've seen with functions, there's the local scope and the global scope and all that stuff. Like I was mentioning on the last slide, if you have a function that conflicts with a function from some package, you can easily just rename that and give it a different name. And then you also make sure that you within a certain file, you're only importing the stuff that you actually need. You're not you don't have too much code all in one place. That can take some time to load your program and all that stuff. But if you just have all of your code in various different packages and modules, then each application only needs to import what it needs, and it's scoped to just what it needs. So it doesn't have to be able to access all these other different variables and functions that maybe the function doesn't need. Then its scope only includes what you've actually imported at that point. Yeah. Any questions on this? Okay, cool. So Python packages. Python is very popular among developers nowadays, and one of the reasons to that are mature, pre-written, easily available packages to do various tasks. So here's just an example of a few packages that are out there that are readily available for you to install and import to your Python environment. So there's the Pandas package. Pandas is an open source data analysis and manipulation tool. So one of the things that Python's become pretty big in lately is, related to big data, predictive modeling, all this kind of stuff, and various data analysis and data analytics type use cases. And Pandas is heavily used in that case. So it has a bunch of functions and packages and data types that make it really easy to work with data at scale, and to manipulate data. And it makes it so that, by importing Pandas, you don't have to write all this custom code to make sure that you can do all this data analysis and manipulation. They've already taken care of that for you, and all you have to do is import it, and then you're good to go. So Numpy, kind of a similar thing here, but it's often used in conjunction with Pandas in big data and data analytics applications. But it's a library that supports multi-dimensional arrays and matrices and high-level mathematical functions. So this one is also really useful for analytics type use cases. Basically, you just import that, and then you don't have to worry about figuring out how you're going to implement this array that has 10 levels of nesting or whatever. Numpy can really make that a much simpler process. And also, evaluating that multidimensional array as a matrix, because say you're trying to do some linear algebra on your matrices in your multidimensional array. You don't have to implement that code yourself. You can just use Numpy to do that. And there's also some high-level math functions to operate on those matrices for facilitating that linear algebra approach there. So super useful for that use case. Requests. So requests is a very popular HTTP library for performing various HTTP actions with ease. So essentially, every time you're navigating the internet, you're executing HTTP requests. Your browser is really what's executing all these HTTP requests for you. So every time you go to a web page, that's going to be executing an HTTP GET request against that web page. Every time you're filling out a form and then hitting send, generally that's going to be a post HTTP request that happens there, where it sends that data to some URL using that the data you've entered in like a payload to that URL. And then there's a bunch of different other HTTP requests requests out there. Excuse me. So, GET is for like retrieving information, like getting a web page. Post is for sending information. And then there's like put HTTP requests. Often that's used for updating information. Same with the patch HTTP request. And then there's a delete HTTP request for deleting resources. All this stuff. If you ever get into REST APIs, which are huge in programming, that's probably something that you might want to, look into for a project, is what a REST API is, how you might develop one, and how you work with them. The request package will be really helpful for testing and using that, because you can execute those HTTP requests against your API application using the request package. And then there's Flask. Flask is a really popular micro web framework used for web development use cases. So it really facilitates or simplifies developing a website using Python. There's another package called Django that it's a heavier package, but it's also used for web development use cases. But it's not just a micro web framework at that point, because so the difference between Django and Flask is Flask doesn't necessarily come with like databases and all that stuff already provisioned in your web application, whereas a Django application does. So there's different packages for different use cases. Flask is for like a relatively simple website, or where you want to have like a lot of flexibility in exactly how everything's implemented. And Django is used for maybe a heavier, more database oriented type use case there. But you know, there's a ton of different packages. These are just 4 that I've mentioned here, but there's tons out there. Looking at PPiAI right now, which we're going to talk about in a second, I can see there's 292,000 projects out there. So tons of different packages that you can install. You just need to find the right one for your use case, install it, import it, and then you can use the functions and variables that are available within that package. But not all packages need to be installed like that. These ones would need to be installed. They don't come pre-installed with your Python distribution. But there are others that do come pre-installed, so all you really need to do is import them. So a package we've already worked with is the IO package. It contains functions for operating system level operations like input-output or IO operations. You know, we've already used this one. We didn't have to do any installs to make that IO package available. All we had to do was import IO into our environment. So that one comes pre-installed when you install Python. So it's not, the functions in IO are not already available in your Python runtime environment until you do the import statement, but you don't have to do that extra step of installing them. It's already available there. Same goes for the math package. So math comes pre-installed and it contains various predefined mathematical functions and values. So something you might need for your assignment is, something you will need for your assignment is the value of pi. And the math package is going to help you obtain the value pi. So it has all sorts of other functions as well for like calculating various mathematical equations and things like that. Like the math package would have, you know, in one of the assignments recently, you had to create a factorial function. The math package would already have a factorial function existing in it. So the math package is super useful in that way, and that's why one of the reasons why it comes pre-installed. There's also the Sys package. The Sys package contains functions and attributes of the Python runtime environment. Not going to get too deep into what that means, but you can pass around arguments and stuff between files, or when you like execute a file, you can when you execute a file from the command line, you can pass it arguments to that file, and you would use the Sys package for accessing those arguments. You can access your runtime environment's path. So one of the things that with Python is it has this concept of a path, and it's like the path to typically the path to all of your packages, and then that's like pre-referenced in your code, so that any package within that path is easily accessible to your Python environment. But the Sys package can allow you to dynamically edit your path. Don't do it, at least not right now. It's maybe something you'd want to do down the line, but it just know that it's there. Then there's also the datetime package that comes pre-installed. It contains date and time related functions. So say you want to know what time it is right now, you can use the datetime package for that. You want to figure out what the difference between, you know, the time now and you know, yesterday at 2 p.m. was. You want to know exactly how much time has elapsed since then, the time delta between those two times. You can use the datetime package for that. So it's super useful for anything date and time related. You know, that would be something that would be kind of a pain to implement, especially when you've got to consider things like daylight savings. We've got daylight savings coming up tomorrow. So, you know, the datetime package already has a lot of the logic for handling that included. You don't have to figure out, okay, how do I take care of the you know, the use case where suddenly time shifts by an hour twice a year or something like that. And you don't have to worry about time zones either. You know, like right now I'm in the mountain time zone, and the schedule that I've given for this class is in the GMT time zone. If we ever had to figure out, so, you know, say it's 1 o'clock in GMT, what time is it in the mountain time zone? You can use the datetime package for helping with that. You probably need another package, the TZ package for time zone, but you know, it still stands. It integrates well with that package. Yeah. Questions on Python packages?
Yes, David. Just one quick question. Just want to know if Pandas, Numpy, Requests, and Flask are free of charge.
Yeah, so all of these packages are going to be free. It's open source. So all you have to do is just install it, and then you can use the code there. That's one of the coolest things about Python. It's Python itself is an open source programming language, and then most of the packages that are developed on top of it are open source as well. One thing you have to consider with certain packages is that they do have licensing agreements. So when you install a package, there will generally be a README file associated with that package, and you just want to read through that and make sure that there's not any stipulations around that package. So like generally things are going to be open source, and you can use it as you want. Oftentimes you just have to include that README licensing notice within the package. So you, like when you import it, you don't want to delete that file from it. Or when you install the package, you don't want to delete that README licensing file from there. But then there are others that are like, yeah, this is free to use for fun, but if you're going to try to use this in an enterprise level application, like say I wanted to use that for work at Comcast, they might be like, okay, in that case you need to do this, and that. So they can have various stipulations for how you use certain packages. But at our level right now, where we're just learning programming, most every package is like, yeah, you can use it for free for learning purposes. A lot of packages are like you can use it for free across the board. But then there are definitely some packages that are like, if you're going to try to make money off of an application that heavily uses this package, we need our cut, kind of thing. So you just need to look into the licensing agreement of that package, and we can get into that later. But yeah, many are open source, completely open source. Great question.
Thank you, David.
Of course. Any other questions?
Yes, hello, David. Please, it's not actually a question, it's a request. I want to know if it's possible for you to send us the link to download, especially the Pandas. Because if you go online to download most of these things, when you click, they will link you to to their website trying to advertise their product. When you click the thing, either it will return 404 error and the rest of them all. But if you give us maybe you, because you are good at that, you will be able to provide us with the direct link to download them. It will be helpful to us.
Yeah, definitely. Yeah, so we're actually that's actually the next slide. So that's a perfect segue into the next slide, how we're gonna go about installing these packages. So great comment. Yeah, you're just a little ahead of the game, of course.
Thank you very much. I appreciate it.
Yeah, of course. So yeah, so perfect segue there. We want to install packages, right? So in order to install those packages, say we're trying to install Pandas here. Let's just go with requests because that's one that I have in the example here. We're going to use Pip. Pip is a package management system for Python that facilitates installing and managing Python packages. Its name is really a recursive acronym. Pip equals Pip installs packages. So, we have pip in here again, so you can kind of recursively go into that, and it's pip installs packages, and you can keep going into that. That's what the recursivity of that means, but that's generally what pip stands for, is pip installs packages, and it comes pre-installed with most Python distributions. If you really just get like, a raw Python executable, maybe pip won't be included there. You might have to go install pip, and the internet has plenty of tutorials on how to do that. But generally it does come installed with pip already. And then if you need a package that isn't pre-installed with your Python distribution, we can use pip to install it. So here in this code, I've tried to import requests, and you can see it's underlined in red here, and there's this like red bubble down here, and it's telling me like module not found, basically. There's no such requests package in my environment. So what I can do then is I can go into my command line here, and I can do pip install requests. Sometimes if you're on a Mac, you'll want to do pip3, because if you use just pip, then pip will try to install it to your Mac's baseline Python 2.7 environment. But if you're using a Windows machine or or anything, then you can just use pip normally. But if you're using a Mac, you'd want to do pip3 here. So I really should have put pip3 here, because then that specifies I want pip3, so the one referencing my Python 3 environment, to install requests. And then after doing that install, now my import request is no longer underlined in red. We're good to go. The package is all installed to my environment, and I can now use it. When this install happens, it actually installs it to the Python path, the path variable that I was talking about with sys. So now, since path is included in every execution or in every Python file, now it's able to access the request package through my Python path. So you can find and read about available packages and how to install and configure them on PPiAI.org. So PYPI.org, and that has a bunch of different packages. You can search through projects to find them, and it'll tell you like the exact pip command to use for installing that package. And then generally it'll have links to documentation as well. Any questions on pip? It's something that I'm gonna show you PyPy and stuff in a few minutes here, and as part of the demo section of today's lecture. All right, great. So some additional resources, you can read up on Python modules from W3 Schools. You can read up on Python packages from pythoncourse.eu. There's this page from learnpython.org about modules and packages, and then a link here to PyPi's website for finding other packages, external packages and such. Cool. So let's go to PyPi's website and just kind of see what's here. So this is the pypi.org website. And you can see this is, the number I was looking at earlier. The interesting thing is I was looking at this when I opened it this morning versus opening it just now. This morning there were 292,208 packages or projects. Now there's a whole 70 more projects. So this is updated pretty regularly. More packages are added regularly, and all that good stuff. So you can search for a specific project here, or we can just browse available projects. You can look by framework, by topic, by programming language, by operating system, all this good stuff. I'm just going to search for requests in here. So there's a bunch of different request packages here. Typically what you're going to want to do is the most popular one, because it'll sort it by relevance. So this is the most popular request package. This is the one we want to look at. So you come in here, and something to be careful about here is just, when you see these other ones here, just generally be careful. You want to look through and make sure that you're getting the right version, because you never know what kind of other code, somewhat like potentially malicious code, someone might have put into into an unknown package here, because it's like request 5, request 3, request 2. We want normal old requests. So we come in here, and this is request 2.5.1. So the 2.5.1 here is just the current version of requests. We can see that here where it says latest version and the release date of that latest version. So this version was released on December 16th of 2020. And you can, in here, it shows you the install statement you'd want to use, and you can just click this button and it'll automatically copy it to your clipboard. So then you can paste that into your terminal or command line environment for installing it. And then it'll generally have some information on the package here. So requests is a simple yet elegant HTTP library. They have some example code here. You import requests. You can do a request.get. So this is executing a get requests against api.github.com/user. And the authentication that you're passing in that get request is a user and password authentication. And then the response from that is going to be a request object. You can get the request status code. So, if you were mentioning earlier about doing, you get a 404 response. The 404 is not found response. That status code means that the page wasn't found. Here, though, we're getting a 200 status code. Anything in the 200 range means that it was a successful request. 300s And then there's like 300s and 400s and 500s. 400s mean something went wrong that you might be able to fix generally. A 500 means something went wrong on the server side and you're not necessarily going to be able to fix. Sometimes you can fix it if you know enough about the backend system, because maybe it's something wrong with your particular request, and the application isn't properly handling that error, so it returns a 500. But if you know enough about the application, you might be able to fix what you're sending so that it can properly be handled. But yeah, the request response has headers that you can return. It has encoding. It has the text is the actual response from the request, and then you can get a JSON object from it, and it's talking about disk usage and private gists and all that good stuff. This all really depends on what is returned by your call to by your request call up here, but don't worry too much. I know that this all is pretty high level. When you actually get some practice with it, it'll make a little more sense. So yeah, just more information on here. Allows you to send HTTP requests extremely easily. No need to manually add query strings to your URLs or form encode your put and post data. But nowadays, just use the JSON method. It's one of the most downloaded Python packages, pulling around 14 million downloads per week, according to GitHub. And yeah, it's also depended upon by 500,000 plus repositories. So requests is used in 500,000 plus other projects. So this is a really popular project here. You can see the various downloads here. So 133 million downloads per month. It's supported in Python 2.7, 3.5, 3.6, 3.7, 3.8, and 3.9. It's an open source package, so you can see the number of people that have contributed to it. It's 408 contributors to that package. And then here's just some information on installing requests and supported versions. So since it's available on PPiAI, we can use Pip Install Requests. Sometimes you can prefix it with this Python-M. Generally, you don't need to do that. As long as pip is included in your path, you don't need the Python-M. But yeah, and yeah, request officially supports Python 2.7 and 3.5. It has, supported features and best practices, so some information on what's supported in this package. And then we get our API reference and user guide available on Read the Docs. You'll often see a Read the Docs link like this. And this Read the Docs link is a link to what it sounds like, the documentation of our package, basically. So this has a lot more information on how to use requests. So we see the same exact code that we saw on the PyPy page and the similar features and explanations. Then down here, you can see like there's a whole user guide here, and you can get all sorts of information. This is all just the documentation on requests. So, you can say you want to make a request. How do you make that request? It'll walk you through how to make that request, the various HTTP requests that you can send, passing parameters, all that good stuff. So you can read all about how to make a request. You can read all about what comes in a request response and all that good stuff. So super useful package. And this documentation request is some of the best documentation out there for sure, because it's such a heavily used and well-known package. You're not always going to get something as nice as this, but it's good to know that it exists. So that's PyPy and installing packages in a nutshell. One other thing I wanted to go through here is, let's see, let me just create a new file. So I just wanted to do that so I'm not showing answers to the other assignments. So something else you can do with PyCharm for installing packages, say you don't want to use pip, and I highly recommend doing this anyway, because this will install it to your virtual environment. You come up to your PyCharm thing up here, and then so you come up to PyCharm up here, you go to your preferences, and in here I have, and then you'll see a project in here. Expand that, go to project interpreter, and then in there you'll see your interpreter. It's my virtual environment up here, and then these are all the packages I have installed currently. So I have requests installed already. Let's say I want to install a new package. I can click the plus button down here and say now I want to install Pandas. I can search for Pandas in here, finds Pandas, click install package down here, and this is going to take care of like the pip install and all that stuff. So another super useful thing for using PyCharm. It makes everything really like a graphical user interface simplicity there. So now you can see installed successfully. Just close out of this window, click OK here, and now I can import Pandas as PD. That's one of the things that's just a convention. You always import Pandas as PD. Don't ask me why. That's just how it is with Pandas. Anytime you read Pandas documentation, you'll see it referenced as PD. Cool. So any questions on that before I review the assignment for the week? No questions?
It's fine by me, David. Thank you.
Cool. Sounds great. All right. So let's go over the assignment real fast and then I can review the answers to the assignments for the last couple weeks since I wasn't here last week to go over it. So modules and packages. For the assignment this week, create a package in the project named geometry. Inside the package, create 2 modules. For Q1, create a module areas.py that has 3 functions in it. Calculate the area of a circle based on radius. Another function, calculate area of a rectangle based on length and width. And function 3, calculate the area of a square based on side length. And then for Q2 here, create another module, volume.py. And this should also have 3 functions in it. Function 1 calculates the volume of a cylinder based on radius and height. Function 2 will calculate the volume of a cuboid based on length, width, and height. And function 3 will calculate the volume of a cube based on side length. And then for the second part of the assignment, call the functions defined in both the modules from a Python file outside of the package. And then a note down here, use the math package to get the value of pi for calculating area of a circle and volume of a cylinder. It's the value you're going to need instead of trying to, type out that value, because pi just, goes on infinitely. We can just use how it's stored in the math package, and then you're good to go there. So yeah, that's the assignment for the week. Any questions on that? All right,
no
great.
Until we try it out.
Say that again, sorry.
I said we don't have questions yet until we try it out.
Cool, sounds great. All right, well, thank you so much for joining today. That's it for this week's lecture. I'm gonna go ahead and stop the recording so that I can go over the assignments for the last couple.